right, here we have a situation where we have energy. We have a certain amount of energy at the beginning. Well, that'll be our green energy, and a certain amount of energy at the end. That's our blue energy. We'll write expressions for those in those colors to keep it straight. So now we have the ball comes to its maximum height, so its velocity is 0, so its kinetic energy is 0. So we have all potential energy over here. Over here we have some potential energy, but it looks like our total potential energy here, all right, total potential energy here is greater than our potential energy here. The only way for that to be true is if right here we have some what?
Kinetic energy.
Kinetic energy. All right. So it says V naught, and since we're solving for V naught, I guess we got to figure, hey, we got some kinetic energy because we got some velocity. All right. So now what we're going to do is set these things equal to each other, right? Is there any work done by non-conservative forces? That's another thing we have to keep track of. All right. What forces are acting on it? Gravity, normal force. So we don't have to worry about the normal force because it's perpendicular to displacement, so the work done is going to be equal to 0. I feel like we've heard that before. All right, so now this is our initial energy in green over here. We've got kinetic energy and we've got potential energy. All right, so over here we've got kinetic energy plus potential energy. Whoops, except we don't, because what do we not have?
No kinetic energy.
No kinetic energy. All right, so now over here, now we'll say that kinetic energy plus potential energy initial, I'll put little knots there because we're feeling naughty, is equal to, terrible, is equal to our potential energy at the end. All right, so here, again, I won't make the joke again. All right, so now our kinetic energy, what is our kinetic energy at the beginning? How do we do that? What have mg squared plus what's our potential energy at the beginning? All right, mg h naught, okay, is equal to, that should be v naught, right? Because that's what we're solving for, and that's what is equal to potential energy is equal to mg h final. All right. So now they say they call this 3 and they call this 4. Isn't it just as true? We will get exactly the same answer if we called this height right here what? 0, and we called this 1, right? We'd get exactly the same answer because our delta H is going to be the same. 4 minus 3 is the same as 1 minus 0. So typically, that's what we do when we set up a problem. We just go ahead and call our initial position, our initial vertical position 0, because it all works out mathematically the same. So now we are trying to solve for the initial velocity. So what's something that's convenient about this? Notice there's something that we didn't get. No, they don't. There is something that does cross out. Yeah, we can cancel all the m's out. Notice it never gave us m if you were kind of going, I don't know how to calculate just because I don't know m. All right, you got to remember, if we solve things algebraically, which I've been stressing all year, there are lots of times where those sort of convenient things can happen for you. All right, so now what do we have? We have V naught is going to be equal to 2 times the square root of 2 times, what do we got over here? We got GH minus G. You know what? Let's just do it a step at a time. All right. Now let's just do it one step at a time. We got 1/2 V naught squared is equal to GH minus GH naught. Okay? Which is equal to G times delta H, right? But we'll just leave it as is. We'll multiply each side by 2, and then we'll take the square root. So V naught is equal to the square root of 2G times H minus H naught. All right, so now we're going to plug all that stuff in. All right, 2 times, what is G? 9.8 meters per second squared times H minus H naught, 4 meters minus 3 meters. All right, so that's what I'm saying. If it was 1 and 0, it'd be exactly the same thing. All right, so then we get dimensional analysis. Thank you. All right, so meters times meters divided by second squared, meters squared per second squared, square root of that, meters per second. Okay, dimensionally. It's good to go. All right, so now V naught has got to be equal to, anybody, square root of 19.6. 4.42. Sounds good to me. 4.42. Let's go with 4.4 meters per second. unless you